Very good evening, everyone, and very good evening, sir. Is it audible to all delegates?
Yes, sir. Volume is somewhat low, sir. Volume.
Okay, just. Very good evening, sir. Now it's audible?
Yes, sir. Yes.
Yeah. So, again, warm welcome and very good evening to all delegates and our respected resource person, Dr. Puneet Kumar Gupta, sir. We again welcome you all to today we are completing the module 4 on basic statistical analysis using R. So after that, there is one more session that will be on 13th, introduction of machine learning. So without taking too much time, I just we again welcome sir to continue the session and to lead the session. Please welcome sir. Sir, please unmute first. Yeah, it's unmuted at your end.
Now am I audible?
Yes, audible, sir. Very good.
Okay, fine. Thank you, Dr. Amit, for introducing and giving me the opportunity to speak on the topic R related to various statistical area like descriptive statistics, hypothesis testing, correlation regression, and today we will be binding with ANOVA and group comparisons using R. Okay, so first of all, I would like to take any doubt if any. Dr. Santosh, I think, no, Dr. Ajay. Dr. Ajay or any other participants if they have any doubts so far. Otherwise, I will start continuing the session. Yes, Dr.
No,
Ajay.
sir. We can continue.
Okay, so we can continue. Let me first share my screen. So today topic is ANOVA and group comparisons using R. So again, I will try to create some background that why ANOVA, why group comparisons, and from where we have left the hypothesis testing. So basically, hypothesis testing, we started with the one population, or you can say we started with one sample t-test, where we were testing the average of one population. Then we moved to two independent sample. And there was another case, two paired sample. Okay, so for that we use independent sample t-test, and for this one we use paired sample t-test. Here we were having two groups like before, after, pre-post, and here we were having two independent groups, right? So today we will be doing extension of these two, like group comparison. Here also we are doing group comparison. So this also you can also say this test, or you also can say group comparisons, because we are comparing two independent groups. But that part we have covered on second day, that is hypothesis testing. Okay. So ANOVA and group comparisons, I thought it is related to more than two groups. Okay. So if instead of two independent group, you have multiple like K groups. K can be any number greater than 2, not is equal to, it is greater than 2. For K2, you have independent sample t-test, and if K is greater than 2, doesn't matter, you have 4 categories, 4 groups, 5 groups, 10 groups, whatever is the value of the K, we use one way ANOVA, simply I'm saying, right? ANOVA is a short form of the term analysis of variance. Okay, so basically the test is analysis of variance. In short, we start calling it as ANOVA, right? So one test we will be doing one way ANOVA today. That is the extension of the independent sample t-test. Again, we were having pre-post observations, but the same day I have given the examples, there may be more than two groups or the observation may be taken at more than 2 times. Like earlier it was pre, post or before, after, but sometimes we do a follow-up study where we take the observations at various point, right? At the time of the admission, after 4th week, what is the condition of the patient, after 8 week, after 3 month, after 6 month. So that means you have observations at various stages, right? And since the observations are of same patient, like at the time of the admission, 1st week, 4th week, 3rd month, 6th month. So these observations are paired, but these are more than 2 observations. So that's why we will be using, we will be extending this paired sample t-test, and it is called repeat measure ANOVA, where your measurement is repeated, right? You are measuring the same thing, but at various time points. Like at the time of the admissions, you note down some readings. After 1 week, same reading. So measurement is same, but you are repeating the measurement at various point of time. So second test we will be covering today is a repeat measure ANOVA. Repeat measure ANOVA. Okay, again, both the tests have the assumptions of the normality, and in case your data is not normally distributed. So instead of the ANOVA, ANOVA is a parametric test, and the alternative of one ANOVA is 𝐎𝐧𝐞-𝐌𝐨𝐧𝐭 test. Okay, so that is the third test today we will be covering. And again, if the observations are paired and more than 2, but the assumptions of normality is not there, so non-parametric version is Friedman test. Okay, so in total we will be covering today 4 tests. Number 1, ANOVA. Though ANOVA is again have one-way ANOVA, two-way ANOVA, then multivariate ANOVA. In short, we start calling it as MANOVA, right? But we will be dealing with the one-way ANOVA. Okay, I'm just doing extension of independent sample t-test. In place of 2 group, we have multiple group today, and I'm denoting these multiple group by K. So one-way ANOVA is the one test. Then alternative of the paired sample t-test, or you can say alternative of one-way ANOVA non-parametric test is 𝐎𝐧𝐞-𝐌𝐨𝐧𝐭 test. Second, for paired sample t-test, the extension of paired sample t-test is repeat measure ANOVA. Repeat measure ANOVA. And again, the non-parametric alternative of this is Friedman test. Fried. Okay, so that's how 2, 3, 4. These 4 tests we will be covering. First 2 are for K independent group. K independent group. Even all 4 are for K groups, but in first 2 groups are independent. And again here we have K groups, but they are paired or dependent. Okay, so that is the story of the entire session that we will be covering today. If you have any doubt in the concept that why or which, in which condition we should apply which test, that you can ask. Otherwise, I will move to one by one to all the 4 tests, right? So first test is ANOVA, analysis of variance. So ANOVA is a statistical method used to compare the means. Like in the independent sample, one sample we were comparing only the mean, population mean of 3 or more independent groups, or even you can write K independent groups, right? To determine if there is a statistical significant difference among the groups among them. It assesses whether the means of the group differs significantly based on a single independent variable. Like groups are multiple, but variable is only one, right? Like height, but height we can be differ by gender wise, male, female. So there are 2 groups, but the variable is only the height. right? So here again the variable is 1, but this variable has 3 category or 3 groups. That's why I'm saying multiple group or group comparison. For example, suppose a researcher wants to compare the effectiveness of 3 different medications on reducing blood pressure. So blood pressure reduction data is collected from 3 independent groups of patients and each receiving one medication. So we can compare with the help of since groups are independent, so we can use one way ANOVA to answer this effectiveness, right? If I talk about, I have separately written that how it is different from independent sample t-test. So independent sample t-test compare the mean of 2 independent group, right? While ANOVA compare the mean of 3 or more group, or you can write K groups, K independent groups, right? So we should use ANOVA instead of t-test when more than 2 groups are being compared. To avoid inflated, you leave it for the internal things, but the concept is that we want to compare more than 2 groups, okay? If I talk about theoretical part, so there is a concept of ANOVA table. Earlier we were having the T statistics and we were checking the P value of the T statistics. But for ANOVA, we use the F distribution and the statistic is F statistics. So interpretation again will be same on the basis of the P value, right? But that is the structure, that is the calculation part. That's how you need to move. So first of all, you need to calculate manually SS between, SS within, SS total, then degree of freedom. It is basically number of group minus 1, total number of observation minus number of group, and total that is always the total number of observation minus 1. Then SS is divided by K minus 1, you get MS. Similarly, SS within is divided by degree of freedom of N minus K, then you get MS within. And then MS between upon MS within will give you the F statistics value. So this value is F calculated value, but since you will use the software, so we will be directly testing. So basically, if you do pen paper, it takes half an hour at least to solve one question of ANOVA manually, right? Because there is lot of calculation in the one way ANOVA, right? So I will straight away will move to a numerical or the case study, and we will be solving it using the R, right? So a clinical trial compares the effect of 3 different diets, right? Diets are independent because they are different. On cholesterol level in 30 patients. Patients are independent, like for first 10% they have diet A, for next 10% they have diet B, and for next 10% they have diet C. Now perform a one-way ANOVA to determine if there is a significant difference among the groups, right? So if I talk about the H0 and the H1, so in like there is no greater or less sign, because you can compare two groups, one is greater or one is less when you have only two groups. But when we have more than two groups, so we will be always checking the equality or not equality. So especially in ANOVA, your H0 and H1 are always fixed. H1 will be mu1 is equal to mu2, like that was the 4 independent tests. Now you just extend it, how many groups you have. So this question H note is mu1 is equal to mu3, means they on an average they all groups are equal and not equal. Whatever is the question, if you are comparing 3 group, that will be always your H note and H1. However, if H note get rejected, that means H1 is accepted, then there is one word, post hoc analysis. Post hoc analysis, what he's do that, yes, there is a significant difference, they are not equal, but which groups are not equal? Then we do pairwise comparison. We do again testing between mu1 and mu2, mu2 and mu3, and mu1 and mu3, right? In SPSS, you will find the option of post hoc analysis. In R, it is also there. But usually the primary investigation is whether the groups are equal or not, right? So manually, that's how a solution will look like, but I have not shown the how we get this because we have certain formulas and it takes half an hour at least to calculate these values. But that's how the answer will be written. I will show you the directly will take you to the R code that how manually because multiple group comparison have a very long code, so I will be manually calculating ANOVA for only ANOVA. For next three tests I have given direct R command because coding is too much, and being a medical professional, since you are not too much with the code, if I write a formula and I say you that you write the R code for the same, you will find difficulty, right? Earlier, till yesterday, things were not too well large. That's why I was showing both manual and the direct command. But since you can see, I have cut down the program and even it is coming on the entire slide, right? Because there is a lot of calculation. So let me explain you manual R code that how we have moved to the R code for one way ANOVA. First three commands are for your data. Even I have written that enter the data. रो डेटा फॉर ईच डाइट ग्रुप हैशटैग है, तो ये भी नेक्स्ट लाइन है क्योंकि स्पेस नहीं था इसलिए कुछ लाइनें मर्ज की हुई हैं मैंने. देन आई हैव क्रिएटेड cholesterol where I have defined three diets. I have basically combined all the three diets in the cholesterol variable, and then I have created their data frame, right, by replicating each diet 10 times. So basically 10 times it will be written diet A, diet A, diet A, diet A, diet A, and accordingly diet A in the first row their value will be associated with these diet A. Okay, so basically it is 10 bar diet A 10 times. I will show you in the R code. Then first of all we calculate their individual mean and the overall mean, right? Then we calculate sum of squares in these commands. Then we calculate degree of freedom, second column of your ANOVA. Basically the third column, if you also consider the SS and the headings also consider as a column. Then it is second last column, and then it is the last column. And if you are calculating p-value, then it is the final last column, right? So this p-value, I have framed all the outputs in the form of the ANOVA table. Like calculate individual हुई हैं, but finally इस command के through मैंने उन्हें एक table में represent करने की कोशिश की है, right? So let me move to the R now. Copy हो जाएगा क्या को? Now I'm copying the entire code. I'm moving to a new file in RStudio. Okay, I have pasted the entire code. Let me first tell you that how the data is created. Now, if you see diet, so diet A is written 10 times, diet B is written 10 times, and diet C is written 10 times. Okay, and again you can print the cholesterol variable. Cholesterol, I have combined all the 30 values. So I have two columns where in which diets are written, and second column the values are written. So let me run the entire code now. Some mistake is there, undiet -1. Okay, some space is there. DA between unique diet. एक्चुअली वो माइनस का डैश बन गया है वर्ड का, वो डिफरेंट हो रहा है. Now it is correct again. Okay, cat. These are two comma. ये merge क्यों नहीं है मैंने ना स्पेस की वजह से. Okay, now you can see the outputs. Okay, so you have sum of squares between the treatments, between groups, within groups, and the total. And basically you have to see that the p-value, right? And since p-value is less than 0.05, your H0 is rejected. That means they differ, the diet differs. Cholesterol differ diet-wise. Now I'm coming to the direct command. Now you can see the code that here up to we have entered the data only. That is only the one line. One line replaces the entire code. Okay, so let me again move to the whether we are getting the same results or not. Now I'm moving. First let me see how I prepare the data frame here. So now I'm entering data. So see, that's how I've created the data. 10 times diet A and their respective value, 10 times diet B, their respective value, and 10 times diet C in their respective value, right? Now just run the commands. So P value is 00577, and here what was the value? 0057, right? So from both either the direct command or the manual command, manual calculations, both are giving same results. And okay, so that's it. You can say since p value is greater than less than 0.05, H0 is rejected, which leads to the like cholesterol is level is different for all the three diets. Yes, significantly differs for all the three diets, right? Any doubt, Dr. Ajay, or any participants in one way ANOVA?
Hello.
Hello.
Yeah.
Yes.
Sir, in independent t-test, both groups may not be equal also, but here all the three groups must be equal or what, sir? Here, equal observations.
Right. See, when you are comparing two things, okay, you are sure that they can be equal, they can be greater, they can be less, and they cannot be not equal. Okay, यदि मैं आपको दो वैल्यूज बोलूं तो आप बता सकते हो कि ये दोनों आपस में बराबर हैं, कौन सी बड़ी है, कौन सी छोटी है, कौन सी नॉट इक्वल, राइट? But when you have three things simultaneously in one sort, you cannot say which one is greater, which one is less, or which one is, because you have to compare three things now.
Yes.
Right? So that's why H naught is fixed, mu1 is equal to mu2 is equal to mu3, while in H1, mu1 not is equal to, because you cannot say, you cannot write. Okay, this is not tested. बड़ा छोटा आप दो चीजों में कर सकते हो, तीन में नहीं. Right? So when you have multiple groups, your H1 will be always of not equal to sign. First is to prove or to check whether they are equal or not equal. If they are not equal, it proves that they are not equal. Then you go for pairwise comparison. Mu1 and mu2, mu1 and mu3, and mu2 and mu3. Okay, so further three testing will be done if your null hypothesis is rejected, which is the case in this example also. Okay, and then we use, since now we come to two group only, here you can use independent sample t-test. कि तीनों का एवरेज डाइट का एवरेज कोलेस्ट्रॉल बराबर तो नहीं है, ये तो प्रूव हो गया, बट किस में बराबर है, किस में ज्यादा है, किस में कम है, उसके लिए आपको पेयर वाइज कंपैरिजन करने पड़ेंगे. So first pair mu1 mu2, second pair mu2 mu3, third pair mu1 mu3. Okay.
So actually, my doubt is the three groups should have equal observations or what, sir? This each group 10, 10,
Yes,
10.
yes.
That is my doubt, sir. Actually, in
Each group
independent,
each group H naught is each group have equal observation. Equal observation means, okay, you are asking a
yes,
size N1, N2, N3.
yes, sir, yes, sir.
If the group are independent, they can be different. If they are paired, yesterday in the
Yes, sir, yes,
second day
yes,
I have told you, in the
yes, sir. You
paired
have
sample,
told.
it is a compulsion, they will be same. In
Yes,
independent, they can be different.
yes, sir. That thing only I have asked. Here, I know also that applies or what. Uh, Independent means the number of observation may is somewhat vary also.
May differ.
Okay, sir. Okay, sir.
Here it is, though by default each has 10 values, but it is not necessary. One may have lesser values because group are different.
Difference. Thanks.
Okay, so second example. So the thing is same. The only thing which is changed that now you have paired observations. Now the groups are not independent, they are dependent. Okay, so it is an example of, it is an extension of paired sample t-test. In paired, you were having two groups before, after, pre-post, but now you have three groups at different time of point. Okay, the percent is same, but you are getting the observations or reading more than 2 times. So I have given example, clinical trial measures the cholesterol level of 10 patients at 3 time points. Okay, so cholesterol level note किया गया है 3 time point पे. Before treatment, what was the cholesterol level? After 4 weeks, what was the cholesterol level of same patient? And after 8 weeks, right? And now they want to know whether there is a significant difference in the cholesterol level over time. तो क्या cholesterol level change हो रहा है over a period of time, right? That is the objective. Again, the formatting will be same. You will be having an ANOVA table and you will having different formulas for them. यहाँ degree of freedom change आया है, वहाँ n-k थी, यहाँ change हुई है, और इनके formulas change हुए हैं, but the concept is same. You go for the p-value. If it is greater than 0.05, groups are equal. There is no improvement or there is no significant change over a period of time. If they are not, if it is less than 0.05, yes, there is a change over a period of time, right? So that's how we test the effectiveness of anything. ड्रग दे रहे हैं तो ड्रग देने से जो रीडिंग्स हैं या वो हेल्थ कहते हैं ना, हेल्थ इंप्रूव हो रही है. हेल्थ इंप्रूव हो रही है मीन्स वो रीडिंग चेंज हो रही है, राइट? So let's take one more numerical. So before treatment data is given, what is the question? A clinical trial was conducted to evaluate the effect of a new diabetes treatment. ओके, सो डायबिटीज ट्रीटमेंट 5% का शुरू हुआ. सो बिफोर ट्रीटमेंट व्हाट वाज द ब्लड ग्लूकोज, आफ्टर 4 weeks what was the blood glucose, and after 8 weeks what was the blood glucose, right? So since patient is same and 3 times data is taken from the same patient, that's why this is paired data. Now it is a compulsion that number of observations in each group should be same, right? So again, the concept is same formatting, only the calculation and the formula gets changed. Okay, so I will directly move to the R code. Here I have written the direct code. Okay, I have not written the entire because it takes hour for me also to write the entire code, all the formulas. So I straight away go, this first 2 lines are for data entering and that is 1 line for applying repeat measure ANOVA, right? It will give you this answer. You straight away go to that p value. It's almost 0. It is 10 to the power minus 6. That means it is 5 times 0, 7. It is like 0.000000741. So you can straight away say, since p value is less than 0.05, even less than 0.05, H naught is rejected. ओके, रिजेक्टेड ये आर भी बताता है, यहाँ 3 स्टार लगे हैं ना, तो R is also saying that ये 3 स्टार कहाँ है, 0 पे आए कि 0% लेवल ऑफ सिग्निफिकेंस पे रिजेक्ट है। 2 लगे होते तो इस पे रिजेक्ट है, 1 लगा है इस पे रिजेक्ट है, और इन पे तो कुछ नहीं लगाता, यानी ये 1% से स्टार्ट करता है स्टार लगाना। बट यू हैव द कंसेप्ट एच नॉट इज रिजेक्टेड एंड दैट मीन्स देयर इज ए change, significant change in the glucose level over a period of time, right? ट्रीटमेंट के 8 हफ्तों के बाद अब आप ये देख सकते हो कि जब एडमिट हुआ और 4 वीक, इन दोनों 4 वीक में कुछ इंप्रूव हुआ, राइट? या चौथे से 8वें वीक में कुछ इंप्रूव हुआ, हो सकता है थोड़ा चेंज इन 4 हफ्तों में हुआ हो, थोड़ा चेंज इन 4 हफ्तों में हुआ हो, ये आपस में सिग्निफिकेंट ना है, यानी ये सिग्निफिकेंट ना है, ये सिग्निफिकेंट ना है, लेकिन 0 से 8वें हफ्ते में सिग्निफिकेंट आ जाए, राइट? So that is pairwise comparison, and that is called post hoc analysis, right? Let's move to the third one, 𝐬𝐲𝐬𝐬. So it is alternative of one-way ANOVA, right? One-way ANOVA has the assumption of normality, but if the normality is not followed, like जो हमने सबसे पहला टेस्ट किया है आज, यदि उसमें नॉर्मलिटी नहीं आती तो हम 𝐬𝐴 पे जाते हैं, दैट इज नॉन पैरामीट्रिक टेस्ट एंड दैट इज पैरामीट्रिक टेस्ट, राइट? फॉर इंडिपेंडेंट का नॉन पैरामीट्रिक अल्टरनेटिव है मैन विटनी, तो मैन विटनी का एक्सटेंशन है ये, राइट? ऑब्जेक्टिव वही रहेगा सेम अनोवा का, but the only thing is assumption is not satisfied, or especially the normality and the continuous data, right? Either if you have the ordinal data or if the normality is not followed, then we can go for the 𝐬𝐴-𝐬𝐴 test. Here we have different concept. H statistics is proposed by 𝐬𝐴-𝐬𝐴. These are 2 authors who proposed this test. They given this formula, which is rank based formula, right? You directly calculate the value of H and get the p-value. If p-value is less than 0.05, your H note is rejected, otherwise accepted, right? So again, I have taken one example. A medical study was conducted to evaluate the effectiveness of three types of pain medications, okay, in reducing pain scores in 15 patients. The pain score was given between 0 to 10. So you have to use the KW test to determine if there is a significant difference in the pain reduction between 3 medications, okay? So medications A, B, C has been given, and you have to test whether there is a significant difference or not. So I have directly written the R code. These two are for data entering, and this is one line for applying the 𝐬𝐴-𝐬𝐴 test. Let me copy it into the R. I think I missed to show you the outputs of second one, repeat major ANOVA in R. But even I run the code, and whatever output I have written, I have also pasted in the slide. But this test, let me copy the code. 𝐬𝐴-𝐬𝐴 test. There is some spacing error is there. वही है ना, मैं कोड पीपीटी पे ले जाता हूँ ना, कोड रन करता हूँ, पीपीटी पे ले जाता हूँ, वहां से इधर लाता हूँ ना, कुछ चेंज आ जाता है, क्योंकि इस कोड को मैं पीपीटी पे पेस्ट करता हूँ, ये पैराग्राफ की फॉर्म में पेस्ट होता है, फिर मैं एंटर मार मार के लाइनें बनाता हूँ, वही एरर है। अदरवाइज आई हैव रन ऑल दी कोड्स। लेट मी रन इट लाइन बाय लाइन। कोई ब्रैकेट छोटा हुआ है। 16×48 48 ही वैल्यूज तो What happened in the previous questions, माइनस का वो दूसरा डैश बन गया, तो ओनली वही कॉपी पेस्टिंग में इश्यू आया. एक ब्रैकेट कम है लास्ट में. नो इट इज डन. नहीं, अभी भी नहीं हुआ है. नो डन. ओके, इस लाइन में भी कोई गड़बड़ है, कुछ कर लो. इसमें ब्रैकेट छोड़ गया है. Okay, so that is the output. P value is 0.812. That means your null hypothesis is accepted, or yes, there is no significant difference. जो भी डेटा था, कोलेस्ट्रॉल था कि मेडिकेशन था, पेन स्कोर था. Okay, so even after the treatments, there is no significant difference in the pain level of pain scores over a period of time. Not over a period of time, between 3 medication type. यानी ये देखा गया 3 टाइप के मेडिकेशंस हैं अलग अलग पेशेंट्स को, क्या इक्वली पेन रिडक्शन हुआ है या नहीं हुआ है. सो पेन रिडक्शन इज सेम, एवरेज पेन रिडक्शन इज सेम फॉर ऑल द 3 groups, right? So let's move to the final test for today, that is Friedman ANOVA, and that is the non-parametric alternative of repeat measure ANOVA, right? So again, it is an alternative of repeat measure ANOVA. So if in repeat measure ANOVA your normality of assumption is not satisfied, even I have written like in situation where the assumption of parametric repeated measure ANOVA such as normality means यहाँ कंटिन्यूस डेटा की भी एक एजम्पशन है. 2 एजम्पशंस जनरली होती है पैरामीट्रिक टेस्ट में. One is data should be normal, and one it should be metric data. That means interval ratio scale. So if they are not met, we can use the Friedman test as a non-parametric alternative, right? So example, I think it is the same which I have used for repeat measure ANOVA. You had treatment, before treatment reading you have note, after 4 week, after 8 week, right? So formula again like 𝐎𝐧𝐞-𝐌𝐸, it follows chi-square distributions, and this is the formula for Friedman ANOVA, right? NKI square. Okay. So again, the same example I have taken, which I have explained you, I think, for the repeat measure ANOVA, right? So before treatment readings, after 4 weeks, after 8 weeks, and this is the R code. So let me again copy the R code. हेडिंग इसकी चेंज कर लेना, हेडिंग कॉपी पेस्ट हो गई है. हेडिंग इज फ्रीडमैन ANOVA, not 𝐎𝐴𝐴. I will say the PPTs, but you change the heading. Let change it. The last code is for Friedman ANOVA, not for 𝐎𝐴𝐴. मैं सॉफ्ट कॉपी में चेंज कर दे रहा हूँ, ये फाइल शेयर कर दूंगा. मैं पेन से कर दे रहा हूँ, क्योंकि कोई चीज शेयर करो गलत लिखी हो वो ठीक नहीं है. Friedman test. Okay, so the code for Friedman is this one. Even I have run the test and below is the output, but let me take you to the again it will give some error, I think. No, this time it runs. So this is the output. I have copied on my PPT. ये 2 स्लाइड हैं तो इसलिए इस पे भी काट दे रहा हूँ. Lidman test. Okay, so interpretation is same for all the type of hypothesis, whether parametric, non-parametric, go for p-value. Since here p-value is less than 0.05, so H naught is rejected. That means there is significant difference over a period of time. तो जो ट्रीटमेंट आप दे रहे हैं वो सक्सेसफुल हो रहा है, साइंटिफिकली ये इंडिकेशन है इस कंक्लूजन का. सो दैट्स इट डॉक्टर अमित फ्रॉम माय साइड. इफ एनी पार्टिसिपेंट हैज एनी क्वेश्चन, आई विल बी हैप्पी टू आंसर दैट.
Thank you so much, sir. And now I request to all delegates, please clarify your doubts if having any in this module.
And doubts from all the 4 sessions you can ask.
Yes,
Any
yes.
question from all the 4 sessions if you have any doubt. Or even the entire workshop you have attended, you can ask any doubt.
Just one doubt. Difference between this one-way ANOVA and two-way ANOVA. Two-way ANOVA.
Okay. Let me again share the screen. See, patient 1, patient 2, patient 3, right? Or even patient's gender I'm noting down, right? Some may be male, some may be female, right? Here you have group 1, group 2, group 3, right? So far what we have concentrated between the groups, right? But if you want to test the effectiveness or the difference between the patients or the various groups or various demographic factors or variables which exist among the patients, like group wise तो difference है या नहीं है, that we have tested, but क्या gender wise है? So gender is another dimension in the same problem, right? So that is 2 way. 1 way is gender wise, 1 way is group wise. आप एक डायमेंशन और ले आएंगे वो 3 वे हो जाएगा, और 2 से ज्यादा को वी स्टार्ट कॉलिंग मल्टीवेरिएट अनोवा या मैनोवा, राइट? So 1 way ANOVA is only the one-sided comparison, and that is group comparison between the groups, right? 2 way is you take another variable into the picture, whether gender wise between the groups and between the genders. Then this is 2 way. You bring also one more variable into the concepts, then 3 way, and then multiple way, right? And repeat measure ANOVA also can be 2 way, 3 way. Today we have covered only the 1 way, right? Factorial design, then we move into the design of experiment, basically CRD, RBD, LSD, Latin square design, randomized block design, फिर factorial design आते हैं 2 की power and 3 की power and designs. So lot of things are there into the pictures, but to start with, you try to understand these concepts, you will be able to generalize them.
Yes. Yes, sir. Thanks.
और कोई क्वेश्चन अजय?
No, sir. When we reading theoretically by ourselves, it may confusing, but when we ask questions, it is very clear. So, sir, that's why I've asked, sir, for clarifying.
No. You keep trying, and still you have any doubt in the future, you can take my number from Dr. Amit, and
Okay,
I
sir.
can,
Thank you, sir.
right?
Thank you, sir. Thank you.
So is there any other query from any other delegates? If there is, please ask. Because we have only one session left and we are just completing this program. And this is the introductory program. That is why it's 1 month. And after 2 or 3 months, we again come with a 2-month certificate program in detail. That is on R. So keep practicing till when you go for advanced program. So is there any doubt, please?
Sir, I have shared with that geometric mean one. Sir, can sir shared?
Geometric mean?
Sir, in community medicine, we have one concept, human development indexes. To calculate that particular index, they have used geometric mean. I have seen. So briefly, just to know what is the geometric mean. Just
Geometric mean, see, there are three types of mean: arithmetic, geometric, and harmonic.
yes.
Like for the speed related question, we use generally the harmonic mean. Right, so concept is there that which type of structure is need to be applied, and accordingly we use that particular respective mean. So concept of BMI, I think you are saying, na? BMI or
No, human
HDI.
development in HDI.
HDI you are saying. So that concept first has to be understand, because the structure will be like the formula for geometric mean is x1 into x2 into x3 and the whole to the power 1 upon n. Right?
Yes,
So
sir.
structure need to be understand first, that why we are using geometric mean in this case, not arithmetic mean on harmonic mean. So that I cannot explain because I don't have the
No, sir.
concept, or I don't know the concept of
No, sir. In
HDI.
general, you explained in HDI they have three factor as you explained x1, x2, x3. Based on three indices, the human development index will be calculated.
That can be no. See, I will not be able to clear you because until unless I know the background. Because whatever
Yes,
I taught, even in all the 4 days, whatever I taught you, I have not started with R. I have started with the background, the story, why, where, and then we move to the R. So first concept is need to be clear. Then only I can explain that
yes, sir.
why geometric mean in that particular case, not arithmetic, not harmonic.
Yes.
Thank
I want to add one thing. Just as sir said that diabetic mean is just an a fruit of product, as sir said formula. Yes. So,
yes,
but in SDI, that is just life expectancy index and education index and income index. That is
yes.
the part of advanced program. You get,
Okay.
and I will share the code for that. I think you will understand. First, in that you have to just calculate the product of that
Yes.
life expectancy, education index, and income index, right?
Okay, sir.
So I will share the code. I have just written half code, and I will share by.
Code is nothing, just you type SQRT bracket open bracket close. Within type, you type PROD product. For product, we use the prod command PROD bracket open bracket close. Now within bracket, you enter your vector.
Yes,
You will be able to
definitely.
calculate geometric mean.
And Dr. Ajay, if you go for manual, then you just define the input like life expectancy and other mean year schooling, and as per I received your picture, then define the
Yes.
constants, then calculate the dimension index, and then education index, income index, and
Yes.
calculate the SDI then, as you know the formula already for SDI.
Yes, sir.
So is there any other doubt? So we can bind up the session. So find no doubt. So thank you so much all. And as we wrap up the module 4 on basic statistical analysis using R, I want to take a privilege to opportunity to sincerely thank you all for to participation, and a special thanks to gratitude our goes to our respected resource person Dr. Puneet sir for delivering sessions with such a clarity, energy, and accessibility, and the expertise and approachable teaching style have made these concepts more understandable and enjoyable for everyone, as I feel. And as we move forward, I encourage all of you to practice and apply this knowledge to you have gained in your work. So once again, thank you so much, sir.
Thank you, sir.
Thank you, Dr. Amit, and thank you, Dr. Ajay. At least I
Thank you,
was
sir.
happy that at least one participant was asking the question, because
Yes,
teacher feels happy that
Yes.
like we see that someone is learning. If someone is learning, he will be definitely will be having the doubts and the questions, right? So teachers gets happy when participant ask questions.
yes, that's the one
Doesn't matter.
always.
Sometimes we are not able to answer the question. We have to look back we answer another day, but we feel happy once participant asks the question. So thank you, Dr. Ajay.
Yes, sir.
Thank you, Dr.
Thank you, sir. Thank you
Amit.
very much. This our program actually in starting of my statistic learning, I have joined our statistic workshop, but I didn't understood anything, sir. But after joining this workshop, from basic, this is structure from basic. That is the I very beautiful this thing from basic to advanced. From so I have learned something in this program about R. Actually, I will telling students R is very difficult. Is very difficult before joining this program. You should experience it. Now I feel this is also somewhat easy. That is the change in my life.
You keep doing practice. I think teaching material will be shared to you. At least I have said you start doing practice and you join the advanced program.
Okay, sir. Thank you, sir. Thank you.
So thank you so much, sir, again for your time.
Thank you, Dr. Amit, and I will share the today PPT with you. Right? Thank you so much.
Thank you so much, sir, and thank you all. This is the end of today's session, and there is a last session on 13th at 6 p.m. Be on time, and then we will complete the program. Thank you, everyone. Thank you so much, sir.